We're going to take this, we're going to run this code here. So it's module 5. So I'm going to say Python module 5 py. So basically what it has done is, let's see what it has done. So basically it has created a file b.txt. We have a string, it has written that string into it, then it has closed the file and it has opened in the read mode. So now you can also open it again to add it in the append mode. We'll close it, close the file handle, and now what we'll do is we'll add some lines to it. So for that we'll have to change this. We give the same file name, we say A, which is append. Okay. The rest of the modes I have already shared in the Excel, in the PowerPoint. You can take a look at that. So now we need to write stuff to that, right? So if I write, this is the second line. I can also add one more. This is the third line. So let me just close this now and I can read it up. And now I'm going to open it up in the read mode and I'm going to read again the same loop. Okay. So if you see here, this file is a free open file. It doesn't contain any functions. So so far we were creating functions. So you can also have this kind of free file where you just write code and it will execute from the first line. So let's go here and let's run this. If you see here, this is we have not added enter here, so that is why it's telling this is the new file, this is the second line, this is the third line. So first it opened the file and then it appended to the file. This method, if you for working with directories, we'll have to import a module called as OS. So within OS there are a number of methods here. If you say get seed OS CWD, it will give you the current message, current directory. So how do we do that is we go over here. So if you to show you the current directory, you can also change directory. You say chdar. So to know all the methods within a module, how to find that out is you can also use the import OS method or OS module to get the current working directory, or you can also give something like os.chdr to change the directory. So this way you can move across directories also. So this way you can change directory to any parameter. You can give some parameter C : test or something. Okay. So basically this is the long and short of file handling. So basically in this we created a file, then we worked on the file, then we appended a file. Now we can also work in binary files or advanced file processing also, that is given to you in Python. So these are some of the benefits of the file handling part. Now let's look at the exception part, how to create an exception. Exception, what are exceptions? Exception, let's look at the exception part of it. So any, as we have seen in the slide, this is the demo part. So any unhandled errors can make the program exit. So suppose we want to check those errors and maintain the program flow, then we can use exception handling. So let's see how to do it. It's typically a try catch block. So first you will have a try, then you will say any statement that you want to do will be within one tab. And we'll say except as exception E. We'll have to write the statement like first we'll have a try catch, try block, and we don't have a catch. We say except exception as an exception. So this is the variable now which we can use to find out what is the exception which is fired. Okay, exception is the original class. And then you can also have a finally statement which is not mandatory, but it will always fire. Okay, so let's take a look at this. Finally statement will always fire. Okay, so let's save this and see what's the error here. So right now what we have here is we have not defined X, so we're going to get an error over here. So this is module 6. So let's say 6.py. X is not defined. So if you see here, this is the error message which has got properly handled, and finally statement will always fire. So before it exits, finally statement is fired. Now if you don't give this, let's see what happens. Now suppose you don't give this. Now suppose we don't give this except and finally statements. Okay, so just print X. Let us see what's the difference. So if you see here, it just throws out of the program and it gives you an indent. The problem here is we have an indentation error because we don't need to indent. We don't have a try catch. Now it should be okay. Okay, so now let's run this and see what's happening. So if you see name X, it just gives you a weird error. It gives you the same error, but it's not handled properly, or it just throws you out of the program. So here you have control. Like from the finally statement, you can also go back to any other program or any other statement that you want. This can be nested also. So if you do, this could be a nested try, which could continue program execution after finally. So this is the advantage. So that is why you should always have a try catch block in all your programs. It's a good best practice. Okay.